So now let's have a look at how you would measure periodic time and therefore frequency. So when you measure voltage, you measure vertically. When you're measuring periodic time and therefore frequency, you're measuring horizontally. So you're going across that way. And the number you're interested in, the time-based number, is this number here. This is how many seconds, microseconds, milliseconds each one of these boxes is worth going across that way. So looking at this signal, you've got 1, and you're looking for how many it is for one full wave. So you've got for one full wave, which is that, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9 boxes. And each one of those 9 boxes is 8 micro. So to do that in your calculator, 9 boxes, each one of those boxes is worth 8 microseconds. 8 times 10 to the minus 6. And we'll engineer that. So that's 72 microseconds. That's the periodic time, which is capital T if you're writing it in a formula. And then to turn that into frequency, you do the reciprocal of it, or you do 1 divided by that, which is that wee button there. Which gets you, engineer that again, 13.89 rounded kilohertz. So 13.89 times 10 to the 3, which is kilohertz, or 13.89 thousand. You see the scope's also measured that. It's come out as being 13.783 kilohertz. So that's very similar. Not all scopes measure. So that's that one. Let's change this. And again, I'm going to adjust my time base. There we go. I'll do another readjustment on my frequency. Bring that in. So I can't really see a full wave there, so I'm going to bring it in one more time on my time base here. If I wasn't right on this crosshair here, I could use this control to move my wave about. So I'll put it back where it was. So that's my time base now. So I'm now set to 4 milliseconds, 4 times 10 to the minus 3. And I've got 1, 2, 3, 4, 5, maybe 5.1. Each one of these wee kind of hatch marks here is 0.2 of a box. So I think that's about 5.1 boxes. Let's have a look. Multiplied by this value here, 4 milliseconds. Gets me that. That's my periodic time. And then to go from that to the frequency, I do 1 over it. Gets me 49.02 hertz. It's measuring as being 49 hertz down there. So that's correct. Let's do one final one, change it up again. Okay. So I'm going to use my time base again to adjust out the way. And probably as well, I'm going to use my volts per division to get this to be something I can see a bit better. Too big, the right size. Centred. Doesn't look quite centred. It should have the same above the line as below the line, so I'm still going to move that a tiny bit. Like that. This here, for the start of the wave, isn't sitting on this cross, so I'm going to move that. That's my new value here for how many seconds it is per division, per box going across. So 1, 2, 3, 4, 5, 6, 7 boxes. So I've got 7 divisions, 200 microseconds times 10 to the minus 6. That gets me a periodic time of 1.4 milliseconds. Then 1 over that to get my frequency. I'm getting 714.28 hertz, 710 hertz. That looks good to me. Okay. Now bear in mind it doesn't have to be exactly a perfect number of divisions. If I adjust my frequency even slightly, I can knock that off. So instead of it being a perfect number of divisions, I could have 1, 2, 3, 4, 5, 5.5 divisions at 200 microseconds. So 5.5, 5.5 times 200 times 10 to the minus 6 gets me 1.1 milliseconds for my periodic time. 1 over that for my frequency would get me 909.09 hertz. 915 hertz. On my signal generator, I'm getting 916 hertz. So that would be how you would measure periodic time and therefore frequency.